All right, let's keep moving forward. We are going to look at 10.4, the divergence and integral tests. Now, here's the thing. That says integral, even though it doesn't look like it. Here's the thing. That's the title of this, but we also have a P-series test that we're going to be talking about. So it's more than just that. We're actually going to pull out 3 tests from this one section. So that'll be cool. So if we're looking at the divergence and integral test, the first thing that we want to talk about is the divergence test. This is theorem 10.9, which that's just the theorem number the book gives. It's totally irrelevant to reality. That just is, anyway, the divergence test. Now, this is your go-to test for series. Let's write it. If my series here, that's a sigma, a sub k, converges, then the limit as k approaches infinity of a sub k equals 0. Equivalently, if the limit as k approaches infinity of a sub k does not equal 0, then the series diverges. Okay, so that is the divergence test. Now here's a real big deal when it comes to the divergence test, all right? The only thing that you can conclude from the divergence test is if it diverges. Does it anywhere say if blah, 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 then converges? No. Up here, it uses the word converges. We're saying you automatically have something that converges, so you know that to be a fact. Then your limit will equal 0. But it does not say if your limit equals 0, then it converges. No, 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 no. That is not what's happening here. This is a divergence test. You are only determining if your series diverges. If, note, this is a big one. This test does not determine convergence. Only. That's the word only. That's a little sketchy there, isn't it? Only divergence. And it's just you take a sweet little limit. If your limit, you can do this in your head, right? If your limit does not equal 0, bam, diverges. That's a quick, easy one. Just like whenever we were integrating, we said, what is our go-to method for integration? So tell me, what's your go-to method for integration? Yes, U sub, baby. So you can U sub, but that is your go-to test for integration. Now, if you are doing a series like we are here, your go-to test is going to be the divergence test, because a lot of times you can just do that quick limit in your head. This is the go-to test for series. If you could do a quick divergence test, bam, you're done, right? If your limit goes to 0, then the divergence test is out. You have to do something else, all right? It's just like if you can't do a U sub with integration, then you try something else, right? It's the same concept that's happening here. If you can't do the divergence test, then you try something else. And that's where we're going to come up with a slew of other tests. All right. But this is our go-to test. This is the one that we're going to start with to see if this works. Bam, then you're done. And it's sweet and easy. All right. So here's example 1. Test for divergence. I have the series k is equal from 0 to infinity of k over k plus 1. Right now, in your head, what is the limit of this? 1. Good. Does that equal 0? No. So as soon as you make that determination in your head, then you have to put the work on paper to show that. A lot of these tests for convergence are like proofs. You're making the proof of why this converges or diverges. It's not, very little of this is computational. You're not really coming up with an answer. You are proving why this test is either going to converge or diverge. We had our two little geometric and telescoping tests that actually come up with a value. We're not doing that anymore. The rest of these tests are going to just simply say converge or diverge. So you're just stating a proof, and then your proof is going to give that answer. Okay, so this is a bit of a different approach than what we've done with math up to this point. This is more proof-based to just determine convergence or divergence. Okay, so in our head, we know that's happening. On your paper, you have to write this. You have to write out your proof so that you can have that. But I'm not talking about a big lengthy proof. I'm talking about basic crap here. So if I take my limit as k approaches infinity of k over k plus 1, this equals 1. This does not equal 0. Bam, you did it. Therefore, you can write the series, the words the series, or you can write the actual series out. I don't care which one you do. Diverges by the divergence. Oh my, that's way off. Try again, try again. Test. So here's what I require from you. You could write the series here. You could literally write the words, the series. I don't care, right? Either one of those, that's up to you. But you have to state whether it converges or diverges. That's important. And you have to state what test it is. That's going to be important in order to pull this off. So your answer has 3 components. You have to say the series, or state which one it is, converges or diverges, and then state the test. That is how you know that, right? Okay. Ooh, that was right spot on there. Okay, let's try another one. If I have this one, example 1b, I have this series from 1 to infinity of 1 plus 3 to the k over 2 to the k. All right? Now, in your head, first of all, there's 2 things that can happen right here. Thing number 1, in your head, you can take this limit to determine if it diverges by the divergence test, right? Number 2, you have a monomial, so you could split this up. What do you see about this second part? Geometric, right? And the fact that this is geometric, it's 3 over 2 is my R value, automatic diverges. So here's the moral of this story. When you approach one of these series, you are going to have multiple tools in your toolbox, just like we did with integration, right? You have to, as long as you're proving it and showing the work to back it up, you can't simply give me a 50-50 shot and write the word diverges. That's why you have to do a little bit of the proof work. You have to prove to me how you know this diverges by using what you know about tests. Okay? Okay. So, 2 ways, and we're going to write them both out here because honestly, you could do either one and it's up to you. So here is way number 1. If I'm using the divergence test, I'm going to take my limit as k approaches infinity of 1 plus 3 to the k over 2 to the k. Now, these are exponentials. Look, this is a bigger exponential on top. So if my bigger exponential is on top, what's this whole thing going to go toward? Infinity, right? And infinity does not equal 0, right? So because infinity does not equal 0, I know that the series diverges by the divergence test. Bam, you're done. All right. Here's way number 2. And I don't care which way you do this, right? It's just, how can you prove to me? That's the whole point. So if I split up this series going from 1 to infinity, I have 1 over 2 to the k plus 3 over 2 to the k. And this part right here, I can say in this geometric series, r is equal to 3/2, which is greater than 1. Therefore, the series diverges by geometric series. That's it. By geometric series. I should write on in here because r is greater than 1. That works out better. Now this first part, as we knew and we figured out from the last section, this one would converge and it would converge to a value. But the fact that my r value is greater than 1, then that diverges. I don't care which one you do, right? This is my go-to test, so you can see that. But if your head went to right to geometric series here with this, because it's that monomial, you can do this way also. As long as you are writing down and proving to me, that's up to you. All right? Okay. Let's do another one. Here is example 1C. I have k is going from 1 to infinity of 1 over k. In your head, what's this limit? Good. So if I have my limit as k approaches infinity of 1 over k, that equals 0. Does the divergence test have anything to do with this? No. So the divergence test is inconclusive. And we are going to find out here very next when we do our p-series test, because that's what we're going to talk about very next, that this is a harmonic series and that it does end up converging. But that doesn't mean that everything always does. All right? Okay, good. That's the divergence test.